Hello everyone. Today we'll be dealing with adding and subtracting radicals. So if you didn't watch my previous video on simplification, or you don't know how to simplify radicals, or the radicals, today is the first day you're hearing of radicals, please go ahead and watch my previous video on simplification or simplifying radicals. You need to know how to simplify radicals before you jump to add and subtract it. So it's just a little bit of advice to keep you going, because some stuff might be some gibberish over here. So I'll be skipping some steps which I already taught in simplification of radicals. So let's go ahead and start how to add radicals. Of course, radicals are square root. How do we add square roots? That's basically what is this grammar radicals mean, right? Mathematical grammar radicals. So the way you know how to add two, let's say 2a plus 3a, right? 2a plus 3a, it should be what? 5a. Why did you add it? You add it because they are like terms, right? Good. What if I've given you 2x plus 3y? Are you going to add them for me? No, because they are not the same. So your answer is still going to be 2x plus 3y. So we will be using that mentality we know in adding and subtracting expression that we learn since from our childhood. We'll be using the same thing over here. So let's go ahead and start solving these questions. Now, they need to be like terms, right? So what are the like terms here? The like terms should be the square roots, or I'll call it radicals. They should be the same. If they are the same, what do? You don't add the radicals, you keep them, root 2. And what do? You add whatever they have at the back. So 3 plus 7. Now you have root 2, you keep the root 2, you don't add the radicals inside, like making a root 2 plus root 2. No. You keep, you add what is at the back of them. What is the numbers that are multiplying them? 3 and 7. So 3 plus 7 is what? 10. 10 root 2. That's your final answer. Because you can do nothing with this, right? Based on the simplification, this is the lowest form it can be, right? Okay. So let's go with this. 4 root 5 minus 3 root 5. First thing, make sure they are the same radicals. Once they are the same, you keep it. You don't add the radicals. Remember, you don't add inside, whatever is inside, you don't write them. So you only subtract. Right here is subtraction, so we subtract it. So we have 4 minus 3, which is 1. 1 root 5. So like the way we also write 1x is the same thing as x, you can write 1 root 5 as root 5. So either way, you are not wrong. Okay, there's still an invisible 1 over there, right? So I hope this makes sense, right? Good. So we have 4 plus root 2. Now, as I was saying, before I solve that question, I want to bring another question. I'm going to claim this and write another question here. Let's say we have root 5, 3 plus 7 root 4. Now, this question, if you can see it very well, they do not have the same radicals. So that's the problem of this question. So I'm not going to do nothing with it. I'll just keep the answer as 3 root 5 plus 7 root 4, as I was saying. So this is our final answer, because we cannot add it. They are not like terms. The radicals are not like terms. So I cannot add it. Neither if it was subtraction, I cannot subtract it. So this is the final answer I'm going to keep. Just like the way you know how to add 2a plus 2b, you know you cannot add this because they are not like terms. So you keep the answer as 2a plus 2b. It's the same thing. So bring that mentality of the knowledge of how to add and subtract expression is the same thing we are applying here. Okay, so let's go ahead and solve this question. 4 plus 2 root 3. Now, if you look at 4, this is not a square root. That's one thing. This is not a square root. It's ordinary number. And number cannot add a square root. That means they are not like terms. right? These are not like terms. So this should be your final answer, 4 plus root 3. So you don't have to do nothing with it. This is a 4. It's not a radical, there's a number. And a number cannot add a radical. It doesn't make sense, right? So it's the same thing as a 2 plus x. You cannot add 2 and 2 plus x. It's the same thing as 2 plus x as your final answer. So that's what it means. So what if I've given you, let's say I put 5 over here, and then I made it this way. Let's say I turned the question down. I wrote it this way. 3 root 5 plus 5 root 5. So they should give us, these are items we can proceed on and write root 5. So as I was saying, I've given an example over here. Root 5 has an invisible 1. So you're going to add, you put the 1 over there, and then you do 3 plus 1, which is equals to 4 root 5. Right? I hope this concept makes sense. Now, what if they are not the same radicals? Like 3 root 24 minus 2 root 6. Here, they are not the same radicals. Yeah. You can move on and tell me the answer should be the same thing because there's nothing I can do. That is just what I said right now. Right? So, but there are some cases that you can, play around it and mingle with it, and then you're going to get something, right? So 3 root 24 and 2 root 6, they don't have like terms, but there is something you can do. What is that? Now, 24, can you break down 24? We know root 6, we cannot actually break it down if you want to, but because there's no number, we cannot break root 6. But what about root 24? Can we break it down? If yes, let's go ahead and break it down. So let's simplify root 24. What are the numbers? We have 24 and 1 from the previous video. 24 and 1. We have 4 and 6. Wow, 4 and 6. That means there is a perfect square here. So that's what we're going to use. So let's change this. 3 root 4 times root 6 minus 2 root 6. Now, what is root 4? It's 2 root 6. Now, since the 3 is already multiplying 24, so that means the square root of 4 is 2. Then they have a multiplication over here. So let's write this down. Now, 3 times 2 is 6. Root 6 minus 2 root 6. What happened? 3 root 24 turns to be 6 root 6 because you simplify it now. Now, are they like terms? Yes. Can you subtract them? Yes. So 6 minus 2 is 4. Please do not add or subtract what is inside the roots. You keep it. Okay? So, what about root 8 and root 18? So there is something fishy over here. We know that 8, we can break it down, we can simplify it. Based on the previous video, we did that. Root 18, we did the same thing, we simplified. So which number did we simplify 5 for root 8? The perfect squares are root 4 times root 2. Plus 4, we have root 9 times root 2. I was telling you I'm going to skip some step, right? Because I did the same thing in the last video. So root 4 is 2. Why am I multiplying? Because there's a multiplication in between 5 root 8. So if you have a 2x, what does that mean? That means 2 is multiplying x. It's the same thing. So 4 times root 9 is 3 root 2. So 5 times 2, oh, what can you see? Root 2 and root 2, right? This look good now. It look good. So 5 times 2 is 10. And then 4 times 3 is 12. Root 2. Now you have root 2 and root 2. This should tell you that, oh, now I can add or subtract or do whatever I want to do. So 10 plus 12 is what? 22 root 2. Right? I'm glad that this questions doesn't give us hard time at the end. 22 root 2 is just the basic how it can be. You cannot simplify 22 root 2. And keep it in mind, you cannot add 2 plus 2 and make it 4. Please, you cannot do that. So root 27 and root 32. So let's break it down. Which number do you think can simplify 27? So we have a 27 and 1. We have a 9 and 3. I think that's the both of them we have only. So we pick 9 and 3 because it has perfect squares. So you write 2 times root 9 root 3 minus root 32. What about 32? So let's look for the square root of 32. So we have what? We have 16 times 2. We have 16 times 2, right? What else do we have? We have 4 times 8. What else do we have? I think that's all we got. So we have 16 and 2. So that means root 16 and root 2. So 2 times root square root of 9 is 3. Root 3. Minus 16, that's 4, 2. Now 2 times 3 is 6. Root 3 minus 4 root 2. Now, what just happened in the last problem? The last problem is that we thought we were going to get the same radicals so that we can subtract them. So this case is telling you that sometimes you're going to simplify them and you won't get a radical that are alike, or they are not like terms. So root 3 and root 2, they are not like terms. But you did a good job by splitting it, like by simplifying them. So this should be your final answer. 6 root 3 minus 4 root 2. So when you reach here, you're good. Since they are not like terms, you cannot do nothing. So you're gonna keep your answer like that. So this is just to tell you that it's very, very, very important. Why? That they need to be like terms. Your goal is to make sure they are like terms. If they are like terms, you don't need to do none of this, right? You just add and subtract them, right? If they are not like terms, you keep them. Like sometimes they are not like terms, you have to look whether you can break them, yes or no. Like this, you cannot break it down. There's nothing you can do. You keep it. I gave several examples before. So this, you keep the answer like that. All these three are not like terms. There's no like terms. So what are you going to do? You need to simplify it. Watch the previous video. It shows you how to simplify. So when you simplify, you can get the same radicals like this and this. Then you can do the subtraction or the addition. But over here, when you finish doing the simplification, there is no, like the way I was saying it, there was not like terms. So there's nothing you can do. You can just leave it like your answer like that, and you are correct. And you are very correct. So please do let me know if you have any questions on the comment below. Like, share it as well. See you next time. Thank you very much.